So, this is my presentation about Gnuk. Then it is an OpenPGP USB token implementation. Um, Usually, I think that in Western culture, you guys start your presentation with joke or some humor. But because I am Japanese, it is our culture to begin the presentation by some apologies. Um, Perhaps my selection of dev room would be mistake. I because I am a Debian developer and see the announcement about the FOSDEM. Uh, I just joined this development room, but there are another say hardware security development room or something. But this is my first visit, first joining to FOSDEM. So please forgive my choice. But I, if I understand correctly, that the distribution guys are very have much interest about the integrity of distribution, and usually the developers of any distribution should have his or their GPG key to 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 make sure that the distribution of the packages or any binary can be checked by users. So today's presentation is about the USB hardware token. And let me explain about myself. I am a Gnuk project contributor, say, more than 20 years. And when I was university student, I joined the Gnuk Emacs development for internationalization. And I also do GNU guide development or glibc testers and GNU toolchain development for embedded system. And 6 years ago, I am one of member of GNU GPL version 3 international committee to have a international symposium, international conference. And at that time, we have 4 or 5 conferences around the world for GNU GPL version 3. And we have one in Tokyo. And recently, I am a contributor for GNU Privacy Guard for pin entry feature. And this month, I became Japanese translation team coordinator for www.gnu.org. Those things I have done or I am doing for GNU project. And I'm also a contributor to Linux kernel. I maintained Flip network driver in 1995. And I have ported Linux kernel to Japanese embedded processor 10 years ago or so. These days, those CPU, Super H or M32 are not that common. Japanese semiconductor company is basically loser in the market these days. Everybody uses ARM these days. And yes, I am a Debian developer. For example, I maintain 30 or 40 packages, 30 to 40 packages. But these days, I only maintain actively Gori. Gori is a Conway's life game implementation. And I am also a chairman of FSIJ, Free Software Initiative of Japan. who kindly sent me to this conference. Yes. Well, as I said already, distribution developers should care about integrity of distributions. And usually Gnuk PG is your friend. And but we have a issue where to put my GPG keys. Because when we usually with no hardware support, we put GPG keys under the .gnupg directory. But yes, it is protected by password, but it is not considered secure enough because people who steal your computer can do brute force attack against breaking your password and steal your identity. So the people who really cares about such problem are using OpenPGP card. And if I understand correctly, Free Software Foundation Europe distribute OpenPGP card as a member's card. Yes. And yeah, it is great. But for me, the card reader, possibly large, bulky, is not my friend. It is difficult to bring large card reader. Yes, these days we have a very small card reader, but it is somewhat expensive. And yes, we have another implementation called CryptoStick by German Privacy Foundation. And it is very great thing that it combines the small OpenPGP card and a microprocessor so that it is a hardware token. And it is, I think it is cheap enough, about 50 euro or so. And Gnuk is my development, and which is free software implementation of cryptographic token. Perhaps you are usually that one-time password token would be very popular than cryptographic token. Because some bank distribute one-time password token for their customer, for their network banking system. But today I am explaining my development of cryptographic token, which stores our secret keys. The Gnuk supports OpenPGP card protocol version 2. And it runs on a general purpose processor, and I select STM32 processor by ST Microelectronics. And it supports RSA 2048-bit. And this is FSIJ's official development project. And yes, I explain about Gnuk. Gnuk is famous. Also in Japan, it's a soother for baby. And when it was 2 or 3 years ago, when I developed this project, my son is 1 year old or so. And my son used to be with his Gnuk everywhere, always. And so I put G, and I name my project Gnuk so that Gnuk token can be a SUSE for Gnuk PG user here. Let me explain about cryptographic token. It stores your secret keys, and it performs security operation on the device, such that digital signature computation, authentication, and decryption. And users or anyone has no direct access to secret keys. And how it useful is. We can bring secret keys securely, and on the go you can make digital signature, authenticate yourself, or read encrypted mail without bringing your notebook computer. And you know, the GNU Privacy Guard is a tool for privacy. It conforms to OpenPGP card standard, and we do the encryption operations, and it supports OpenPGP card. And I think that OpenPGP card is popular in Europe, and it is smart card to put Open GNU PG keys. And the feature of version 2.0 is it supports 1024-bit keys to 3070-bit keys. And it has RSA accelerator on the chip. And users can use OpenPGP card with GNU PG, as well as OpenSSH through GNU PG agent. And we can also use the card for client authentication for TLS or SSL. Yes, we have an application called Sqt. It is an NSS module for Thunderbird or Firefox. And we have also a PAM module using OpenPGP card. And I started Gnuk project on September 2010. And I focus on software implementations. And the CPU choice is Cortex M3 based STM32F1, F103, yes. And currently, the target board is Olimex evaluation board. And this is a kind of hackish, but we can use STM32 part of STM8S discovery kit. And I also developed my own board named FST01. The second board, for second board, I should explain more. The STM8S Discovery Kit is a kind of educational kit. It is very cheap, like less than $10 US. But its purpose by STM is education for STM8S, an 8-bit chip. But we are very lucky that it has a gadget. How to say? It's a kind of dongle to control STM8S processor from PC. The dongle uses STM32. So we take advantage of that part of the kit so that we can install Gnuk on that processor, not the main STM8S processor of original intention. So if there are some employee but from STM, I should say sorry about that. But anyway, you can sell more board to the customers. You see. So Gnuk's approach is that I focus on the software and I keep software as simple as possible. And our approach is to implement OpenPGP card protocol, not PKCS number 11 directly. Because public key cryptography standards, number 11 can be emulated on top of OpenPGP card protocol. Say, a good example is OpenSC project. And I keep implementation minimum for CCID communications. And recently I changed to support only short APDU level exchange. Until version 0.16, I implemented short and extended APDU level exchange, but to be conservative to existing software, I concluded that only support short APDU level exchange would be better. Yes. And the implementation contains, I use CBOS RT kernel, and I also use crypto routines from Polar SSL. I use RSA routines and the AES routine and the SHA-1 routines. And it implements CCID protocol and the OpenPGP card protocol and implement flash ROM management. So basically, we use the main flash ROM embedded in the chip. We don't use external chip, but only use the internal flash ROM. And according to the manual, we can lock the, we can protect flash ROM access by JTAG debugger, and once it is locked, there is no way to read out by JTAG debugger or anything. So if I don't have a serious bug for attackers to read out the data of secret keys, we can consider it secure somehow. Yes, it is not secure enough. If we compare smart card implementation, I don't think general purpose embedded chip is more secure. I don't think so. Smart card consider to be more safe than the general purpose processor. But for my purpose, I think that it could be okay. And as of Gnuk 0.17, it has about 9,000 lines of C code. And it is distributed under the GNU GPL version 3 and later. And for RSA 2048-bit for 2048-bit key, it took 1.48 seconds for digital signing. I think I can stand with that. And it means that to sign, say, as I am Debian developer, I sign for my packages, or I sign my board, or I use Gnuk for OpenSSH authentication, and I use, when I log into server, or when I push my code to other Git repository, it takes 1.48 seconds to authenticate. For me, it is okay. But that's because I use general purpose processor and with no RSA accelerator. Then I think that this performance is okay for general purpose. And it is already useful for GNU PG users as well as OpenSSH users. And this slide explains limitation of Gnuk. I use normal general purpose embedded processor. It means that it is not that tamper resistance. It's the tamper resistance feature of general purpose processor is not that great if we compare smart card or other special purpose processor. And it depends on its feature of flash read protection. Yes. And it doesn't have RSA accelerator, and it means that it is not that fast. And technically, we have a limitation up to 2048-bit key. Many Debian developers these days have a 4096-bit keys, so their keys cannot be imported to Gnuk token, unfortunately. And here is a good point of Gnuk. The first good point is it is free software implementation. This is a very good feature. Yes, there is an OpenPGP card, but we don't have the source code of the firmware, unfortunately. But for Gnuk, we have a source code so that you can examine or you can enhance the firmware as you like it. And another feature is that we can develop or test new things. For example, we can change or improve the USB communication. Or actually, I am currently trying to support ECC, elliptic curve cryptography for next version of GNU PG. And I also testing new pin entry for authentication. The device, we need to authenticate ourselves to the device. Usually, we input passphrase to open the feature of digital signing and authentication or decryption. But usually, we use keyboard of personal computer, which is easily how to say, monitored by the malicious software. So some people cares using the card readers with pin pad. But so Currently, I am testing Gnuk implementation so that people can input pin or passphrase locally, not by the PC, but through the device directly. And here I explain the current status. For GNU PG, it works well. And for OpenSSH, it works well through GNU PG agent. And for Firefox, using Sqt, we can use client authentication using Gnuk token. And I created my client certificate using csr.org and tested against that site. But currently, here is the current state that's not supported yet. I don't support secure messaging protocol yet. And I don't have idea to support this. So we have a risk. If your computer is attacked and intruded by some malicious users, and when he monitors the USB traffic by some kind of USB sniffer, your passphrase could be stolen because the USB transmission is not encrypted at all. But we can work around this by supporting pin entry locally. Yes. And currently, Gnuk software doesn't support key generation on device. All that we can do is generating the keys on PC host side and import those keys from host side. And currently, we cannot override keys on the device. So to override keys, we have to remove keys at first. This is a limitation, current limitation. And this is a known problem. And yes, after I implemented Gnuk, and after I used Gnuk extensively, I figured out eventually that OpenPGP card is not portable.GNU-PG. I mean that all the information the device has is only secret keys. So under the GNU-PG directory, we have more than secret keys. We have secret keys, secret key ring, as well as public key rings and trust DB. Secret key has your secret information, but we also have a public key information under the GNU-PG. And we also have a trust DB under the GNU-PG directory. And it means that just bringing Gnuk token means that you can do digital signing or authentication or decryption for your secret key, but you will perhaps not have a public key ring on the go. So if you really want to do more operation on the go, we should have those information on the device. But if I understand correctly, the OpenPGP card specification is for smart card. And the smart card doesn't have enough storage like public key rings. For example, Debian keyring, Debian project has a keyring, and it's more than, I think, the 10 megabyte or so. 40? Oh. And so we cannot put such a large storage on the smart card. But for token, we can do that. This slide explains the supported board more, and I skip. And here is a URL for Gnuk development. And the web pages reside on fsij.org/Gnuk. And we have a Git repository under the gnibe.org, because we don't have a Git repository on fsij.org yet. And this is a Gnuk development requirements. We need Gnuk toolchain for ARM, and I am currently using the script named summon ARM toolchain, and we also need Python and a Python module called PyUSB and PySmartCard, and we also use OpenOCD and Git. Yes. And here is a host requirement. And basically, we tested against Debian and Gentoo. And if you have a fairly new GNU-PG and PCSCD and live CCID, you can use Gnuk token with no problem. And I also tested on Windows, and this only a bit. And here I explain the steps building Gnuk token. Get source code from gnibe.org and prepare a GNU tool chains for ARM. I mean the cross development environment. And then you can build gnuk.elf and write gnuk.elf to STM32 using OpenOCD. And this is an optional step. And you can configure Gnuk token with your specified serial number. When you don't configure serial number, it uses its own chip-on ID for serial number. And then you can personalize Gnuk token and import keys to Gnuk token. Last two steps are same as OpenPGP card. And here I explain using Gnuk token for secure shell authentications. Before development of Gnuk token, I didn't know the way of using GPG key for OpenSSH authentication. But it is not that common, but we can do it. And when we use Gnuk token or OpenPGP card, it is considered very, very convenient, because we only have a GPG key, and we can bring secret keys to somewhere. Yes, but the configuration or settings of SSH using GNU-PG is somewhat difficult, because there are many applications which has a role of SSH agent. So using GPG agent as a SSH agent, we need to stop C-host or original SSH agent and GNOME key link. In usual distribution, those 3 plus GPG agent has a role of SSH agent. So when we use GPG agent as a SSH agent, we should only run GPG agent and not running C-host SSH agent and GNOME keyring. This is a key point. And then we configure GPG using use agent and enable SSH support. Yes, this is a setting using GPG agent as a SSH agent. And here I explain STM8S discovery kit. As I said, it is educational purpose kit by ST Microelectronics, and it is very cheap. We can buy it with 750 JPY. It means less than 8 euro. Yes. And if you have enough technology for do-it-yourself electronics, you can make Gnuk token easily. Here is a STM8S discovery kit. Yes. Oh, I am. And here is a STM32 part. And this is my do-it-yourself JTAG debugger connecting STM32 of STM8S discovery kit. Here is another embedded board. And this is today I bring some example. Yes, this is somewhat bigger, but I build this. It costs only $10 or so, and this is somewhat smaller. Yes. I use hairpin case. And I also did PCB design using KiCad, and it is open hardware. And this is the result. Yes. And here is a future work. As I described already, I am currently trying to support elliptic curve cryptography, NIST P2056 curve support. It's quite fast. It takes only 0.08 second to make digital signature. And configure time, USB vendor ID support, and product ID setup. Currently, we use FSIJ's USB vendor ID. Yes, and currently I am considering about supporting data other than secret keys towards portable .GNU-PG environment. Oh, here is an acknowledgement, Barnakov, Akim, and Giovanni, and Japanese guys as testers. Yes. So this is appendix. Yeah. So shall I have a questions from you? Yes? Any questions? Yes. Oh, yes. For audio recording, you should use this. Okay. Sorry. Oh, got it. This is a switch.
Yeah, that's good. So you mentioned
Yes.
a way how to enter pin entry directly to the token. So you want to add a small keyboard to the token, or what's the idea?
About pin entry,
Yes.
there are two kinds of experimental implementations, and one is using the consumer infrared controller. Yes, usual for say a TV controller or audio controller. If it is close enough, you can use it. But you know that people can monitor the signal very easily. So that's a very it doesn't consider very safe, but somehow you can use very convenient device. Yes, and another implementation I use. I am using file file manager of host side PC. I mean that it pretends as if it is USB memory, and when user drag and drop folders, it considers a key input. So when malicious users monitor the USB traffic, in theory, he can decode the pin input key sequence, but it is very difficult in practice because file folder movement is became the USB mass storage class traffic. Yes, currently we have those such experimental implementation for pin entry. Yes.
Yeah, these are nice ideas. And another question is about generating a key directly in the device. You mentioned it's not supported at the moment. Is it because of lack of enough entropy, or?
Yes, you are right. Yes, but yes, at the beginning I considered like that, but we need enough entropy for ECC. For RSA, we don't need a true random generator for computation of digital signing or decryption or anything, but for it is needed for key generation. So at first, I didn't support key generation, but for ECC support, we need a true random generator. So last year, I implemented my own method for true random generator. I am using the quantum error of ADC, analog digital converter, last bit of analog digital converter, and we use the noise of the we can use the noise source of ADC, and I experiment against the random generation number. I forgot the package name, but there is a very good test suite for true random number generation, and I confirm that the entropy from ADC considers enough. And currently you have enough entropy source on the device. So in theory, we can support key generation on Gnuk, but as a history, we didn't support it. Yes.
Cool, that's nice to hear because I was experimenting with the similar topic, and
Yes.
this is the same solution I was able to create, to just read the last bit of the ADC. But I wasn't sure if it's enough, but if you say that you did some measurements and it's okay.
Yes.
Then. And also some more expensive ARM boards have a hardware generator on board.
Yes, yes,
So
F2 has.
if you are able to, or once the prices of these boards are lower, then you might consider using that as well.
Yes, you're right. Thank you.
Thank you.
Yes. Another question? No, I am running out of my time. So I finished my presentation. Thank you for your time.